So today we'll just work on exercise 9B. This is distributions of sample means. It continues from 9A and it's sort of a segue point into 9C. So what we're going to do today is not going to make a whole lot of sense until we do 9C tomorrow. Nonetheless, there'll be some calculations for us to perform. So what we're talking about is we're talking about some variable that we measure. All right, so it could be height, could be weight, could be anything that we measure. And x1, x2, x3, all the way up to xn, those are the observed values of the measurement. And all it's saying is the average result from n observations is the sum of each of them divided by n. So we'll get straight into an example with A here. We've got bags of peanuts are known to be normally distributed with a mean of 765 and a standard deviation of 8. So that's what we know about the distribution. And then we have 6 bags are weighed and their weight is found to be. And so we have all of these observed values of x. These are the observed values. And what it asks us to do in the first part of A is find the observed value of x6. So this just means the observed value of x6 is going to be all of those added together divided by 6. Now when we perform this, we get 762.8. 3. Repair it. All right. So our observed value of x6 is 762.83. Okay, so that's the first part. That's just like average, right? Is a good way to understand it. Okay. Now we also know that the mean of the distribution, the mean of x, is 765, and the standard deviation of x, so the standard deviation of x being the distribution of bags of peanuts, is 8. So we have those two. That's what we're told about the normal distribution of bags of peanuts. Now, part B says find the mean and standard deviation of x6. So I want to draw you to this point. It's sort of highlighted above, but it says if we have a mean of x is equal to mu, then the mean of xn will also equal mu regardless of n. Okay? What this means, well, the way we should think of it is, if we know the population mean, all right, remember the difference between a population and a sample. So a population might be all year 12 students, and you guys being a sample of year 12 students. Okay, you're a small group that indicates properties about the whole. And all that means is here we know the population mean, and over here we have the observed value. The observed value can be different from the population value, but the population value is always going to be more true. Why? Because it's out of everyone. You guys are only a small portion of that. So all this point means is if we know the mean of x, then that is also the mean of xn. So in this circumstance, we know the mean of x, so therefore the mean of x6 will be 765. All right, if we were to do 100 observations, the mean of x100 would be 765 because we know the mean of the population. In the circumstance where we don't know the mean of the population, if we don't know this piece of information, we take the sample data that we're given and we assume that that is representative of the true mean. Okay, so that's the first part. The second part says find the standard deviation of x6. And if we have the standard deviation of x is sigma, well, the standard deviation of xn is sigma divided by the square root of n. So we're going to have the standard deviation of x6 is going to be the standard deviation of x, which is 8, divided by the square root of 6. All right, so that's what we're doing today, exercise 9B. So it's introducing you to these two ideas, which we're going to reveal in the central limit theorem. All right, so that's what comes up in 9C. Let's